So C++11. The standards, the C++, I guess, they released these official standards, right? And they're like, here is C++, I think 99, they had one in 99. I know for sure they had one in 03, right? And this is the language, and then compiler manufacturers will create their compilers against that standard. Well, I believe in like the 07, 08 time frame, they're like, we need to add all of these cool modern features that are in C++11. And they called it C++08. And then time went on, and it hadn't been ratified yet, so they called it C++09, or I think they called it C++OX, because they're like, well, this is taking forever. Let's just call it C++OX until we actually get it done. So when you see, I mean, you need some special compiler flags to compile the stuff that I've got here. This might help too. Okay. And the compiler flag is std equals C++0x. That's where that comes from. The actual standard was C++11. It was ratified, I believe, in August of last year, August 12th. And to be honest with you, like we'll be going through some examples, and it'll be pretty good. But most of the content of my talk comes from the Wikipedia article on C++11. That's an excellent starting point to kind of learn about all the stuff that's in there, and then you can search on the individual terms that are in that article to learn more about it. Let's see. At the end, I'll give you a couple of I'll give you some links to sites that I found particularly useful. Obviously, like there's one on AT&T.com. It's Bjarne Stolstup's like official FAQ on C++11. That one's pretty cool. Are there any questions? Okay, you were just curious about my attire. That's fair enough. Well, without further ado, let's jump in and learn about some of the cool new features in C++11. And in no particular order. Let's see. Okay. Better, or is it a color thing?
On alias LS, the blue.
Oh, that's going to go away in a second.
Okay.
Why would you torture yourself?
Yeah, it's
Okay. So if you decide to clone the repository, that's what the make file looks like. Basically, I've got like a collection of these CPP or CC files in this directory, and you do make and the executable name that you expect to be built from that CPP file. And we're going to twiddle the flags that we use. Right now, there are no flags. I'm just going to run G++ and then create an executable, just so you know. And then I have a clean function that cleans all the stuff that we make. That's it. So where are we here? OK, so const expressions. Oh, that one might be living out on the machine I used to write this talk.
You did a pull, but you didn't do an update.
Yeah. Well, let's see if I can exemplify this on the board without a marker. Well, let's do it from memory. Do we want to try that? Probably not.
You're a better programmer than I.
Is it in here? Nope. Would you forgive me for a brief moment while I SSH home?
You're forgiven.
Thanks.
The fact that you actually have that all set up is nice.
Oh, here we are. Aha. My code. OK. Whew. So what's going on here? What I want to do is I want to initialize an array of integers. But at least when I first came across C++, I was like, OK, well, I want to initialize an array of integers, but I want to grab it from the internet, or right, this length from the internet or something. But you can't do that, right? You have to explicitly tell C++, if you're going to do it this way without new, you have to say, I need one of size 12, or I need one of size something or other. But let's say, like, anyway, I just want this to work. Can you see kind of what's going on here? There's a function that returns the integer 41, and I want to initialize this integer, or this array of integers to that size. If you run GCC on this, so make const expression, right? You expect this error. Array bound is not an integer constant. Well, C++11 adds this const expression keyword. Oh, yeah. You guys see what I just did right there?
Yep.
OK. I'm just enabling C++11 compiling, which all you got to do is say dash std equals C++ 0x. Right? I didn't test this on my Mac. Shall we go back to my house? Wah, wah. I'm really sorry about this. Let's see. So make const expression. I guess I could spell. Hold on a second.
Try using the number 11 instead of OX.
It's OX. Oh, here we are. I didn't add the to my home machine. Sorry about that. OK, cool. And it ran. What's that?
We're just debugging your
Yeah, thank you. Hey, I'm writing it as we go, so so that's pretty good. Any questions about that? It's supposed to be really useful. I don't know. That's the thing with, so as an aside, like some of the stuff that we go through here, I have found practically useful. I really have found practically useful. Some of the stuff is beyond me as a programmer. I think this is one of those things. I think like some of you are thinking, oh yeah, this I can see how this could be useful. It was the first thing I came across when I was doing the wiki, reading the wiki article. So here it is. Cool new feature. Let's see. Oh, there are limitations with this. See the wiki for limitations. And then you can actually have the constructors of your user-defined types be declared this way as well. Yeah, question?
So this is a pretty simple example that you showed us. I mean, you're not actually like calculating anything. It's just returning a constant.
Precisely.
So can you like pass in arguments and then like what are the limitations on doing this?
Well,
So basically you're asking, is it compile time or runtime?
Yeah.
it's it's just compile time.
Okay.
Yeah. Yeah, it has to be at compile time.
Well, I mean, so you gave the example of like getting stuff on the network. Did you do that with this const expression?
No, I gave that as an example because that's something that I would like to do in Python, but no, it was not.
Oh, okay.
Yeah, so the limitations are right here. First, the function must have a non-void return type. The function body cannot declare variables or define new types, and the body may contain only declarations.
Okay.
So basically it's just a way of not using macros.
Yeah.
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 Okay.
So that was the first cool new thing. Okay. This one, by contrast, the new initializer lists, I have found practical use in these. In fact, OK, so I guess a little bit more history about me and C++. My brother took CS 142 at BYU last semester. Who knew about the C++ language change at BYU?
When I went to BYU, it was C++.
Okay, then they went to Java. We're back to C++ at BYU. And so this was his first, like he took 142 before his mission, came back and signed up for the next class, and they were doing it in C++. So all of the curriculum has changed to C++ except for 240, which was C++, is now in Java, because they still want you to have exposure to Java. Anyways, we could discuss more about that at the end. The obvious answer, right? At any rate, so he took that class, and I helped him in the class. And I thought, well, I've heard about this new C++ thing. I'm going to go along and do some of your homeworks with you and try and learn as much about C++ 11 as I can. Doing that, and so he was doing it with traditional C++ constructs, and then he started seeing my code and being like, oh, wait a minute, can I just do it that way? I'm like, ask your professor. And he was like, oh, yeah, sure, if it compiles, we don't care. But anyhow, so this was the first thing. These initializer lists are the first thing that I found incredibly useful. Okay.
Oh, as a side note,
Yeah.
when you're ranting, if you stand a little bit closer to the screen, I'll be able to catch you.
Okay. So if I stay where I was, I won't be on the video?
Yeah.
Okay.
Your hand's kind of like, I just can't get it wide enough.
Okay, no, don't worry about it. Okay, thanks to know. Thanks for letting me know. Okay. So looking at this code, all right, so I made a struct. Here's one way to initialize variables in C++, right? In a class or in a struct, you do the initializer list up here. Parentheses here, right next to the variable name. You can also initialize strings like on line 13, where you say string and then the parenthesis right next to it. Another way you could do it is kind of through the assignment operator. I think alternatively, you could have also said string s3 equals string. Right? Are you seeing how this is kind of excruciatingly complex, right? And long-winded and what have you. Now they've kind of normalized this idea, and you use braces to do initialization. Let's see. So here's an example of the same thing using the new C++ syntax, right? So you say, oh, that's not going to help, is it? Like here on line 14. Is this good? Am I in?
Yeah.
Okay.
Totally.
Right, so you say the type, the variable name, and then you say, in the braces, you give the arguments that go into the constructor, right? Same thing here. Now this is the one that I found super ultra mega cool. Let's go back to the previous file. And I had this question here. Let's say you wanted to initialize a vector of strings. Like a simple vector of strings, what would you do? Well, you say vector string v. On the next line, v.pushback a, v.pushback b, v.pushback c. Right? Well, let's complicate that problem slightly. Let's say you want a constant vector of strings. How do you initialize that? As an exercise for the interested reader, go and read this Stack Overflow answer. And this is the answer, right? You basically have to take the bounds of some sort of like traditional C array, right? Give the beginning and the end, but the end you have to calculate in a special way. You have to know the size of the things that are inside of it, blah, 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 blah. Totally feasible, right? And this guy has this template thing that he drags around and he uses in all his projects and blah, 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 blah. Well, I find the alternative syntax much simpler, right? This is valid C++ 11. You just say, okay, well, I want a constant vector of strings called s and initialize it this way. Welcome to the future, everyone. Right? Okay, as another aside, so when I started learning about C++, I was also concurrently learning about Go. And a lot of the things that I loved about Go, I was like, oh, wow, they're adding this to C++. Is anyone going to use this? right? Because, I mean, you have Go, or you have these other modern languages that give you these features. Why stick around and use C++? It'll be interesting to see history play out, because a lot of this stuff is pretty cool. Like this right here, that's way better than the Stack Overflow answer. But what if we've already migrated to modern tools? Anyway, just a thought. Same thing with like maps, right? So I have a map of strings to ints. Brace up here, brace down here, and then you do another brace in here, the string, the int. Similarly, right, and I know for sure this will compile. So make new, and it compiled with the warning I had an unused variable, right? I'm fairly certain that you can do this too.
You need one more brace.
Sorry?
With the top.
Yeah, I do. I believe these are just warnings. Yeah, they were just warnings. All right. Next cool new C++ 11 feature. Who was about to yell at me for doing this?
I knew it was okay.
Oh, you knew it was okay?
Yeah. With C11.
Yeah.
Or C++.
They fixed it, right? And it's funny because I read somewhere, I want to say it was in Strustrup's in the FAQ. They were like, all the compiler manufacturers knew how to warn you about that condition. Why didn't they just do it, right? Like, if they all knew how to warn that. Does anybody know why I'm pointing at this? Anyone not know why? Because this is the bit shift operator, right? And so the parser would come here and I don't know how to make this thing here because this is actually an operator, blah blah. But all the compilers knew how to warn you about that situation. They just didn't actually implement. They just didn't do what you wanted it to do. Anyhow.
And the error is quite obscure too.
Right? Well, this is C++ after all, right? You saw how much crap got printed to the screen and it still billed me an executable. So once again, on this slide, I guess, on this piece of code, new standardized, and I had it up here too, new standardized initialization syntax, or normalized, I guess. Maybe that's not even accurate. That's the other thing. Nothing I teach you in here is guaranteed to be absolutely accurate or true or valid. But the compiler won't complain at us for the most part, right? It'll build executables. I am no computer scientist. I'm not like a programmer or anything. But anyways, my dad's a lawyer, so I want to make sure I put the asterisks up, right? And then this cool new extraordinarily terse initialization list syntax. You may note in my notes, they talk about this initializer list thing. I couldn't get it to compile, but it's in the Wikipedia as something useful. You may want to look into it. OK. Any questions so far about this? Type inference. Oh, baby. Who knows what the auto keyword did previous to C++ 11? Yeah, I didn't. They have an auto keyword now. It does not do what it used to do. Let me show you what it does do. I think it's in here. OK. So I've made a constant vector of strings called McQuays. And it's got the names of all the boys in my family. We're just 4 boys. Stephen, Michael, Brian, Derek. OK? Then here I've declared a function int. It just returns 42. Then down here, I'm showing you valid C++. The thing I loved, Byron sees where we're going with this, right? The thing I loved about Go is you could say variable name, : equals anything. And it would figure out, I don't know if it's deduce or induce, but it would figure out what the type was. And you can just run with it, right? So I is of type int, j is of type int, s is of type string, right? This compiles and goes. But now check this out. I want to traverse the McQuay's vector and print each of them out. I'm violating PEP 8 at this point, right? 80 characters. And I've already split it down onto different lines. But look at this thing. Standard, vector, this type. I've got to get this iterator. And I never get this thing right. And I generally use it right? McQuay's.begin. Watch this. Okay. Okay, it ran, prints out the names. Now watch it, still run and print out names.
Oh, nice.
Boosh. Do you see the power? Byron.
The power is awesome, but there's two kinds of iterators you can get out of begin. You can get a constant,
A constant,
and a non-constant. How does it pick?
I don't know. That's a good question.
It's not magic.
It's probably not.
I would hope it picks the constant one.
Yeah.
That's what you want.
I think it picks the const one. I don't know. I actually don't know the answer to that.
Okay.
Are you saying you call .begin, it could return either of two types?
Depending on what's on the other side.
Yeah.
Well, wouldn't it just return which one's on the other side?
Yeah, but
Unless, which one's on the other side?
Oh, okay.
Yeah, it's a valid question. But, I show my brother this stuff in his, when I was doing my code, and he's like, oh, wait, I don't have to write so much. This is awesome. So once again, just in character count, C++ is becoming more modern, right? With auto.
And that's how Go does it. Well, you just put like bar or something.
Yeah, and it deduces, yeah. Let's see.
It is under the hood picking an actual.
It is, yeah, still typed.
It's compiled strictly typed and everything still?
Yeah.
Okay.
Yeah, absolutely. That is a good point to make. C++ is not magically now weakly typed. It's still only mostly strongly typed, as it always was.
It's the compiler figuring out something.
The compiler's doing the compiler did all that typing for us. Yeah. Any questions about that? Oh, and then in a similar vein, you can do stuff like this: decal type of I, J, or C, Q equals. So the type is actually calculated from whatever I's type is. And you can actually pass in, I think, functions and a bunch of different things. I actually have never written code using the decal type, but whenever they talk about the auto keyword, they talk about the decal type function keyword. I don't know. So another exercise for the interested attendee. New string literals. You can actually declare a UTF-8, UTF-16, and UTF-32 string this way.
That is really nice.
I've never gotten it to compile or be useful. So another aside, which we'll get into more later, because I wanted to show you guys some really cool demos on stuff that I find interesting. This doesn't work for GCC 4 earlier than 4.6, I think. So I've got like an Ubuntu LTS 10.04 or whatever that I did all this development on. Nothing was working. Then I had to compile GCC 4.6 from source. And then some of the stuff started working. And then some of the stuff didn't work, so I compiled GCC 4.7 from source. And then even more stuff started working. And then Clang has a similar kind of support matrix. So the trick to this is figure out what you love about the wiki article or this presentation. Then you go and visit each compiler manufacturer's support matrix site. And you go and figure out if it's even implemented, like regex. I was like, oh, regex built into the language, finally, right? You can't get GCC to compile code, any of the code samples for regex. Clang does, but then the Clang that's on my MacBook doesn't compile the initializer list stuff, right? So this is not just an aside. This is like very important. If any of this stuff you get super excited about, be warned that there shall be frustration vis-a-vis compile support.
There be dragons here.
There be dragons here.
So like in 10 years, Red Hat will be able to.
Yeah.
Set to us 6, you're screwed for a long time.
Yeah. So in fact, I'd be interested to know, Byron, on Arch, like whatever compiler ships with Arch, how much of this stuff compiles and runs.
It's just GCC 4.7.
Okay, okay. So
So we have to wait till the next standard comes out before most of this makes sense.
yeah. Womp womp. We'll get to the stuff that I was super excited about and had a hard time getting to run, and we'll talk more about this. But just as a very important aside, there are support issues. It's way better now than when I started looking at it back in like the August timeframe. But yeah, everything I've ever compiled ran just fine. Okay, so tuple fun. Okay, this feature is not something that I've had a lot of real-world use for. But when I figured out that it had this, I was like, oh, this is going to make C++ so much easier to teach to people, theoretically. This is interesting. If you go to the wiki page, it lists out some of the main goals of the C++ standard. And this is worth reading verbatim, actually, because you won't believe me unless you see it on Wikipedia. Right? It was a joke. So what is it? Here we are. Here's a list of why they did this standard. And on this list, right, maintain stability, like here is the goals, right? On this list, and it's C++, I know some of you guys are going to just guffaw, make C++ easy to teach and learn without removing any utility needed by expert programmers. So I would argue, actually, that so far, some of the things that I've shown you, they're going in the right direction, right? So just to keep that in mind, how many of you, when you were first learning how to program, and well, how many of you first learned to program with like C or C++ or maybe even Java? Okay. How many of you, the first time you were writing a function, and you're like, OK, I want to return these 3 variables? Right? Isn't that like so natural? You write a function, Python gives it to you. You can return as many variables as you want. Go gives it to you. You can return a whole list of variables. The first thing I ever want to do when I write a function is like, I want to return A and B, or I want to return A, B, and C. Historically, you couldn't do that, right? But they have this notion of tuples, or tuples. I believe tuple is a valid pronunciation. They had pairs. They have pairs in like C++ 03, right? But now these are generalized pairs. You can have them of arbitrary length, right? So I've made this tuple, right? Tuple int. Here's the name C. Say make tuple 5, 4. If I were to add like a float right here, I could put a float right here. If I had a string after this, I would have 5, 3.14, 4, Stephen. And C would contain all these values. Yeah?
Next question, could you replace the expression tuple angle int angle with auto?
I think that's an excellent question. I think I tried that and it didn't work.
Yeah.
Well, first of all, let's make sure this code compiles. OK, it does. Apparently you can. OK, so how do you get at these things? Well, there is this function, std_get. OK, so some of the syntax is still crufty as all get out. But you say get, the angle brackets, 0, C, this will print 5. OK? OK? So there's still cruft. You're still going to feel the warm, fuzzy C++ crufty. OK, this was one of my favorite interview questions asked me when I was first interviewing for programming jobs. I want you to switch the values of A and B. All right? How do you do that? You create a temporary variable C and you juggle it all around, right? Unless you're using Python or Go or C++. Sit back and let me show you how this is done. Okay, so what does this look like in Go? You say A, B equals BA. Done, right? In Python, whatever. In Go, similarly, or excuse me, in C++, you can say tie A, B, make tuple BA. Okay. I think. Yeah, this is great. Right? 5-1 or 1-0 instead of 0-1. This the 5 was from this cout, right?
That's pretty sweet.
Is really cool, huh? Now watch this. I might not get the syntax right. So let's say I wanted to do this instead. Tie AB equals some func, right? Because like I told you, the whole reason I want to do this was so I can return multiple values from a single function. Let me show you how that's done. I think you can even do it this way. Let me make sure this compiles. It might not work. Oh yeah, I didn't like this one. That's fine. I think you just do a make tuple here. Okay. Let's talk about the syntax. The functional programmers in the room, like the people who really know about programming languages, will tell you that this is really cool. You do auto on the return type, and you actually specify the return type here. There's a reason that's really cool, and I don't really know what that reason is. Sorry. But that's how you can do it now. You can specify the return type after the function name.
So why, what's the point of the auto if you're specifying the return type?
So once again, in keeping with traditional C++ style, this auto actually means something different than this auto. If I read the literature correctly. It just signifies that you had.
I think that goes back to the linker, how it's going to be object code.
Oh, really?
In auto is how it populates the old object file.
Oh. So this is actually the traditional use of auto. This is the, yeah. So like I said, those of you who would miss the craftiness of C++, there's still a bit in there. But this is huge, because for the longest time, that's one of the things I love about Python, is you just return a bunch of stuff from a function, or Go likewise. Oh, I guess I should make it run before you believe me, right? Oh, and I guess I should see that. There. So 5 was from the get example, 1 and 0, they've been swapped. And then I populated A and B with 4 and 2 from that function. How are we doing on time? Oh, have a lot less time than I thought. This is good, because I was concerned about running out of content and then having to watch the Blender Foundation videos or something. So, okay. So lambdas. Lambdas are another one of these things. Who here knows what lambdas are from like other programming languages who have true lambdas? Okay. Okay. Because I'm not really super familiar with all of the really awesome use cases of lambdas. The only exposure to lambdas that I've ever used are in Python. And people complain about Python's lambdas because they can only be, they have to fit on one line, so they have to be like an expression or a statement, whichever one it is. Anyway, it has to be an expression, right? So there's a significant limitation with that. JavaScript, I believe, has true lambdas, and a lot of like Go has true anonymous functions. The only real-world use I've ever had for them, so once again, this is more a testament to how limited of a programmer I am than their actual utility, is with Python. I guess I can show you an example here. Well, I wanted to sort a dictionary in Python, like a key value mapping in Python, according to the value. So you can actually specify a function that will be used, kind of like a comparator function in some of the C++ stuff. And so what you do is, let me just try and whip it out. This might not work, but so Stephen is 32-ish, 1. Michael is 30. Derek is 30. Yeah, I did, didn't I? On Michael. I can type. Oh, I did. Okay, so in no particular order, right? Dictionaries in Python do not guarantee any sort of order. But I wanted to print them out in age-sorted order. So the way you do that is d.items will return a tuple, right? Here is a tuple, Python tuple now, of name, key value, right? This is a Python thing, dictionary items. Key value, key value, key value, key value. Notice these are in the same order, but they're obviously not in the order that I specified. They end up being sorted in, like, I think hash order or something like that. Anyway, they don't guarantee any sort of order. And I want to sort them in according to the age. So what you do is you can say sorted. You can run these guys through sorted, right? And you'll see Brian, Derek, Michael, Stephen. The default behavior apparently is grab the first thing and then sorted by the index 0 of the iterable or whatever in there. That's not what I want, right? I want it sorted by something. So you specify this optional key parameter. I want you to sort this way. So you say lambda x, and you say x1. I guess minus x1. So what that says is I want you to take, so here's this little kind of anonymous function. Sort by the negative of the second index. You see that? So this is the only real-world example that I've come across where an anonymous function was useful.
So question,
Mm-hmm.
with that lambda, do you have the scope of other things that are going on, or do you only have the scope of x?
I believe you only have the scope of it. That's a good question. I don't know. I don't know. But I do know the answer of that in C++. So shall we return back to C++ land?
Yes.
OK. So I just wanted to kind of give you an example of why my understanding of lambda's awesomeness is so limited. It's the only time I've ever used lambda. So this is the syntax right here for lambdas on line 52. You start with the brackets, and you specify what the lambda is going to be able to capture. So this answers your question, AJ. And here's the rules for that. If it's empty, it captures nothing. If you say bracket and you explicitly put something like this, this means x is by value. This is traditional syntax, right? By reference. Y is by reference. Here, grab everything by reference that you can. Here, grab anything you can by value. Here, grab everything by reference except x is going to be by value. Here's grabbed everything by value. So on and so forth. So yes, you can specify that in C++. Then comes the argument list. And then you do arrow optional return type and the body of the lambda. So let me run you through an example of what that looks like in real C++ code. Right? Here's my initialized list of integers, or excuse me, vector of integers. And I want to know what the total is of these integers. I want to traverse this collection and accumulate a total. Right? So I use for each from algorithm. And I say, here's the beginning of ints, here's the end of ints. Now here's where the lambda begins. It's kind of cool because, oh no, it's still, Vim's still kind of, I think this is a Vim complaint about syntax. But here it is, right? Here I want to pass total in by reference. Int x is going to be each of the items here sequentially. Then what I do is I say, well, I want total plus equals x. So there's an anonymous C++ function. Now on this line here, I just print out the total. And then here is an example of I guess it's not necessarily an anonymous function, but I'm capturing this function here, right? So I say auto my lambda doubling func equals, capture everything by reference. I guess I didn't want that because I don't actually use it in here. So this is a typo. This should be nothing, but it'll still run. Integer x, right? It returns an int, and this is what it does. And this doesn't have to be a single line. This can be whatever you want it to do. And I just multiply it by 2. So I've made this anonymous doubling function. Not anonymous. I've made this function here, and I can use it. My lambda doubling function, total, right? So it's going to take total, whatever was calculated up here, and print it out. Bada bing. Any questions? Okay. I hope someday I keep trying to get better and better at the trade. And one of these days I want to learn a functional programming language and learn what is so cool about the lambdas. But C++ has them now.
Feel the power.
Feel the power. OK. So regular expressions and threading. I'm coming to the close now of the talk, basically. Primarily because I wanted to prepare some examples of regular expressions and some examples of threading. I actually have some examples of threading, no examples of regular expressions. But the truth is, I'm going to point you guys at what I was reading in a second, so you may as well just read it there. But that's where I really want to emphasize. Like, it wasn't really all baked into any of the compilers that I used. Right? I had to build bleeding edge GCC. I tried, and I was successful actually. OK, so I wanted to use regular expressions. I tried, nothing worked. Actually, it was worse than that. It compiled and then threw an exception when it started doing regular expression stuff, which was really confusing because then I was like, well, if it's just throwing an exception, maybe I just don't have a modern enough GCC. So I tried building GCC latest, like 4.7. Still did the same thing. And then I read, oh, well, GCC actually doesn't support that. So read your support matrices. So I started building Clang, and then I finally got to build with Clang, but it was like there was a compile option that I was missing, and then I added that one, or compile flag, and I added that one, and it finally compiled. So you can get it to compile, the regular expression examples. OK, I will say one thing that's cool about the C++ support of regular expressions. Who's not familiar with the regular expression literal syntax in Python, where you say R and then you do a quote, and then you don't have to escape your backslashes. So you guys all know about that? C++ has that. Yeah, cool, huh? So you can do capital R, and then there's a whole syntax for doing that, and you don't have to be escaping stuff as much. So that's really cool. The other thing they have is, you know how in C++ you can say something like this. You can say float f equals 12.0, right? You know how you can optionally say that? They now allow for user-defined of these. Yeah. Once again, beyond my abilities. But you can do that. You can do that. That was kind of a cool one that I came across, I think. So I mean, let's look at the thread.cc. This is straight from, and let me actually go ahead and point you at the website, solarianprogrammer.com. So this guy here, solarianprogrammer.com, if you click on C++11, he has a list of blog posts that are extraordinarily useful. A couple of regular expression tutorials, a lambda tutorial, and some multi-threading tutorials. And then these are the ones that I found the most useful. Compiling LLVM, Clang, and libc++ on Linux, so you can get the Clang goodness on Linux. He kind of spells out how you do that on Ubuntu. And I thought he had one in here as well on how to get it compiling GCC as well. Oh, here, building GCC 4.7 on Ubuntu. So if you want to try, if there's stuff in the support matrix that you need GCC 4.7 for, he spells out how to build that. It took a long time on my really crappy laptop that I keep in a closet serving web pages. It took a long, long, long time. But it was cool. I can compile some of the things that I couldn't with the default compiler that shipped with the system. And then, so this example is directly from his site. So who here is not familiar with what it takes to do threaded programming in C++? OK. In Python, you just import threading and you use the built-in threading, right? Perl, kind of the same thing. Go has concurrent stuff built into it. There is no way with the standard, like C++ standard, to do concurrent programming. You reach onto the shelf and grab pthreads, or you reach onto the shelf and grab MPI or OpenMP or any of these third-party libraries to do it. There is nothing built in. Now it's built in. You pound include thread, and you can do stuff like this. Here's a standard thread, T1. You pass it in a function. Call from thread. Then you say T1.join, it's going to run it, and then it's going to join it, and then you return 0. So this is a threaded program. That dumps core. Okay, so my confusion on this note, this was this morning as I was preparing this talk. Don't worry, some of this talk was not prepared this morning, it was prepared earlier. I was like, oh, I want to show this threading stuff, and I figured out what it takes to get it to work. If you look at the make file, for some reason you have to still specify this -p thread. Actually, now that I think about it, I can't recall what the -p is on the compiler. Does anybody know what -p does? For some reason I thought this was pthread, but it's not. It's -p and then thread. I don't know, but for some reason make...
Pthread's in the Linux kernel, right? Is that a confusion?
I know that it uses... Hold on a second.
Usually do -l pthread if you need it.
It's -l pthread, right?
The library, yeah.
Yeah. That's what I'm saying. I'm not sure. For some reason, -pthread. Oh, here you go. -p. I don't know what -p does. Anyway.
There was an
No,
actual,
it's a special option.
Is it a special option for C++ 11? OK. So if you want to do threaded programming using the new standardized threading stuff, and on this guy's site, on the Solarian programmer site, he does demonstrate. He's got a GitHub account, or GitHub repository you can clone. He shows this is what it looks like in standard, like pthread, and this is what it looks like in the new thread stuff. And it's a bit prettier. It is a little bit nicer now with this new threading syntax. So for example, thread 2. So this one's a bit more interesting. We're actually going to launch a bunch of, like a thread pool, right? Like Python multiprocessing pool. We have this little thread pool. We're going to launch n of them. Num threads, I'm guessing, is a constant thing. 10 of them. We're going to launch 10 of these threads, right? Call from thread. Launch from the main, and then we're going to join them. So I'll be honest, I've not done very much like pthread coding, actually at all. All of my threading coding has been in other languages. But this is pretty legible, I think. And it runs. So if you do there, it ran concurrently. And that's all I got. So any questions? Who here did not learn anything? Who here learned something? Mission accomplished. OK, thanks for coming, guys.